Rewrite the equation of the quadratic surface in standard form. Identify the surface. X squared plus 4y squared minus 4z squared minus 6x minus 16y minus 16z plus 5 equals 0. Wow, terrible thing to say 5 times. So what we're going to do first here is I'm just going to rearrange all of the variables so that my x's, y's, and z's are all together. So x squared minus 6x minus 4 or plus 4y squared minus 16y minus 4z squared minus 16z equals negative 5. I wanted to move that 5 over just to kind of get it out of the way. All right, so now what I'm going to do, I'm just going to do a bunch of completing the square. So what I'm going to do first is deal with these x's here. So to make that a perfect square trinomial, I need to take half of my b term, and this is my b term here, this negative 6, and I have to square it. And that's going to give me a negative 3 squared, which equals 9. Now I put that negative 3 squared in there. You'll actually see why later. Okay, so I'm going to do the same thing with this 4y squared minus 16 now. So now I'm going to take these two here. So far, just so we know, I need to add 9 to the left side and to the right side. Okay, now let's deal with this 4y squared minus 16y. Well, what I'm going to do first here is I'm going to pull that 4 out. And this is going to give me a y squared minus 16. Oops, not 16 anymore, 4y. Okay, now what I'm going to do is I'm going to find the what I need to add to make this a perfect square trinomial on the inside. Okay, so what I'm going to do here is I'm going to take that half of b again and square it. That's going to be negative 2 squared, which equals 4. Now I'm not going to add 4 to both sides. Now think of it this way. Now remember, I'm going to put a plus 4 right there, right? So let me show you what that means. So that plus 4 would have to go right here, which means I'm going to have to take a 4 times it. So 4 times 4 is going to be 16. Because I factored out that 4 early on, I'm going to have to deal with that still. So that's actually going to be a 16 that I have to add for my y's to be a perfect square trinomial. So now for my third one here, I'm going to do the same thing I did for my y's, but instead of pulling out a 4, I'm going to pull out a negative 4. And that's going to be z squared plus 4z. And that's still going to equal negative 5 there. So now what I'm going to do here is I'm going to make that a perfect square trinomial here, that z squared plus 4z. So I'm going to have to add a half of b here squared, which equals 2 squared, which equals 4. So again, I'm going to have to do the same thing I did with the y's, because I really am going to have a plus 4 here. And when I multiply that 4 through, that's going to be a 16. But not a positive 16, because that's a negative 4, a negative 16. So now if I look at everything I have to add on the left side, I have to add a 9, a 16, and a negative 16. When I add all those together, it's going to come down to adding 9 to each side. So that's what I'm going to do now, is just add 9 to each side. But instead of writing the 9 on the left side, I'm going to write all these other numbers that I had that equate to 9. Okay, so I'm going to have x squared minus 6x plus 9 plus, now I'm not going to use the original up here for my y's. I'm going to use the factored form I had down here. That's going to save me a step. I like saving steps sometimes. Okay, so I'm going to write the 4 there. This is going to be a y squared minus 4y. And I'm going to have to put this 4 in there, right? Because that's what I'm adding to the inside. And then if I multiply that, then I'll see where that 16 comes from. Okay, so I do the same thing with the z's. So I have a negative 4 on the outside. I have a z squared plus 4z, and then plus 4 on the end. And that's going to equal negative 5. Okay, now what I'm going to do is have these all factored. And that's the reason why I put this middle step in here. This makes it simple. So when I factor that, that's going to be x minus 3 squared. And I don't even have to look at it to tell that. It's because the way this is designed. So this negative 3 here is going to be the second term of my binomial that's squared. And that works for all of these. So this is a plus 4 here. So I'm going to write the plus 4 down. And then when I factor this is going to be that negative 2 because that half of b there was negative 2. So this is going to be a y minus 2 squared. And then for the last one, it's a minus 4, and that's going to be a z, and that was positive 2 there. So plus 2 squared equals negative 5. So that's our setup there for this problem. Messed up on one thing here, guys. This isn't negative 5 here. I forgot to add these together here on the right side. A very common mistake, so I'm kind of glad I did it here so you can actually see. We got to be careful. It's actually a 4 there. Okay, I apologize for that. Okay, so be careful. When I added the left, the 9, I got to also add the right with 9. Okay, so there's our answer there so far. So now my last step is I got to divide by 4 everything. Because to be in standard form, this has to be a 1 on the other side. So I have to divide by that 4. Okay, so this is going to be x minus 3 squared over 4. And those cancel. So that's going to be plus y minus 2 squared. And then for the last one here, those 4's cancel as well. And that's going to be a minus z plus 2 squared, and that's going to equal 1. This is that equation in standard form. Now we kind of have to understand at this point now the equations themselves slightly. Now remember, this one here only has one negative. Okay, whether it be x, y, or z doesn't matter. That just determines on which way it opens up or those kind of things, or which way does it look like it goes to infinity, in which direction. Okay, those kind of ideas come up. But if I have one negative, I can say one thing. Here is my one negative. So the form of this one is, so this will be the general form, and that's what we see here. I guess not the most general form because this one's centered at 0, 0, 0, but a pretty good one. So that's the idea here. So that's the same form we see here, that one negative. So this is going to be a hyperboloid of one sheet. So there's our second answer that we have for this one. Because this one was asking two things here. It said, rewrite the equation of the quadratic surface in standard form, and that's this down here. And then it also said identify the surface, and that's what we get here. That's where we kind of draw this information in right here. So that just gives us what we're looking for here. So that's the problem.